Hello, gang. Just a little bit of a backdrop of why I teach, what I teach, and why I think it's important that you prepare yourself. Um, in our IT program here at FSU, we try to provide as much experience as possible in the various types of technology that you'll be seeing once you get out in the professional world. From the database standpoint, I have here, and as you know, I've had you guys go to this site on a number of occasions while you had me in class. But I have you go to db-engines.com, and one of the links is for ranking. And as you can see, I have the ranking site open here. I'll make this just a little bit larger here so it's a little bit easier to see. But you can see right now that 4 out of the top 5 um, database engines, um, data repositories, if you will, are all relational DBMSs. 4 out of the top 5. And then the other experience that you have, if you're in my classes anyway, at the advanced database level, is using a NoSQL option as well too. And the NoSQL option that we'll be using is MongoDB. The only so we're getting 4 out of the 5 top DBMS experiences in the IT program here at FSU. The only one we don't touch base with is PostgreSQL, and that's because we have experience with Oracle, MySQL, SQL Server, the top 3, and really no need to touch another relational DBMS. I mean, if you want to, you're more than welcome to do that on your own. But uh, I encourage you to consistently uh, watch this site because it gives an overview of how much these DBMSs are used throughout the world and their popularity. So with that backdrop, I'm going to give a little bit of a demonstration here about concerning Oracle. So I'm going to close this browser window here. And you'll see that, well, number one, you'll see that I have the Oracle SQL Developer open at this current time. It is Oracle 11G, and this is the interface for SQL Developer with Oracle, or I should say Oracle SQL Developer. And there's another video that I created on how to log in using Remote Lab. So I'm not going to cover that right now. I'm just going to talk about the nuts and bolts of the Oracle demonstration creating tables. First thing I want to say is do not drop any databases. It's a little bit different working with Oracle and SQL Server and MySQL. We drop databases and create tables. Here in Oracle, you are given a schema, which is essentially synonymous for user. And then inside of the schema, you're given table space for various objects. So again, do not drop a database. You're going to be dropping any tables that you want, and that's fine, but don't drop a database. Okay, so a little bit of a backdrop here. I'm not going to go through all this. I'm just going to be focusing on the creation of the tables and the um, aspects specifically dealing with the data creation as well as populating the tables. But here are some um, Oracle constraints, and I've also discussed this in class in my advanced database course. The Oracle constraints are not null, unique, primary key, foreign key, and check. You could also do constraints using triggers as well too. So that's how Oracle enforces data integrity. One thing I want to draw your attention to is that in Oracle, unlike in SQL Server, Microsoft SQL Server, and in MySQL, there is no update cascade. Now, just quickly, what do we mean by update cascade? The example I give in class is this. You have two tables. You're in a dealership and the dealership has a database. Two of the tables, one is the sales rep parent table, customer is a child table, sales rep ID will be the foreign key in the customer child table. In a delete cascade, what would happen And by the way, the foreign key options are always applied to the parent table affecting the child table. You could always still modify that child table if you needed to. So in other words, if you wanted to um, delete any child records, it wouldn't affect the parent table, but deleting the parent records would affect the child table if you had delete cascade. So as an example, there are 5 records: sales rep ID 1 through 5, auto increment. By the way, Oracle does auto increment a little bit differently as well too, but be that as it may, we have 5 records: sales rep ID 1 through 5, foreign key in the child table, customer, sales rep ID 1 through 5. If for whatever reason we deleted sales rep 1 in the parent table of sales rep, and we said on delete cascade, all of the associated records in the child table, that is the customer table, would be deleted. Now, there is no right way and wrong way. The safe way is to on delete no action. But then again, in a certain set of business rules, in a certain environment, you may want those child records deleted. Okay, so fine. Um, the child records are deleted because the parent record was deleted. We said on delete cascade. But in Oracle, unlike MySQL and SQL Server, we cannot do on update cascade because Oracle, as per the requirements, if you go to chapter 5 in our book, what constitutes a good primary key? Good primary key should not change. It should be immutable. Immutable, IMMUTABLE. Immutable means uh, cannot be changed. And so Oracle maintaining this consistency does not permit on update cascade. And as you can see what I highlighted here, Oracle believes the primary key should be immutable, that is never changing. If you want the primary key to change, then you're going to have to find some other way of doing that. Either create another primary key, delete the existing one, but you cannot change the value of the primary key once it's established. So there is no on update cascade that would affect the child records. All right. So integrity constraints, not null, unique, primary key, foreign key, and the check constraint. So you can read those on your own, do some research on your own concerning Oracle's integrity constraints. I want to draw your attention now to the number data type. Now, just as an FYI, the int data type, decimal data type, numeric data type are acknowledged by Oracle. But behind the scenes, under the covers, what's happening is it being implicitly converted to the number data type. So to make life easy, just use the number data type, including for integers. Now, how is that handled? It's handled like this, lines 17 and 18. That is that the number data type accepts 2 values. In other words, it has 2 arguments. One is for precision, the total number of digits, and the second is for scale, the total number of decimal points, or I should say the total number of decimals to the right of the decimal point. A bit more here. If precision is not specified, the column stores values as given. So if there's no scale specified, the scale is 0. That would make it an integer. Oracle guarantees portability, excuse me. Oracle guarantees the portability of numbers with a precision equal to or less than 38 digits. So here's an example too where you can actually use the asterisk for precision, and it would work like this. In this case, the precision is 38, and whatever specified scale is maintained. So you can use that asterisk for the total number of digits that that would be used, and in this case it would be 38 currently. Um, perhaps later on that asterisk would still be a placeholder, but maybe for a greater number of digits. So when specifying numeric fields, it's a good idea to specify both precision and scale. It provides an extra integrity checking on the input as well as for documentation purposes. All right. Now, the first thing that you want to do, step number one, is to make a connection. Okay. So I'll just do this briefly here. And again, I have an entire video dedicated to that, but I could disconnect this by right-clicking on the top there. Did you see where it says connections in the top left corner? I know I have a MacBook Pro with the Retina display, so the resolution is quite high. But right there, there's connections underneath that green plus sign. I could right-click on this, and I could disconnect it like I did, or I could make a new connection. Um, I'm sorry, I didn't disconnect it. I'm going to disconnect mine right now by right-clicking on my connection. I could disconnect that. So it is currently disconnected. If I put some SQL in here, it wouldn't be acknowledged. But what I want to do is make a connection so that I can create my table. So I right-click on that, and that's what you would do every time you logged into Oracle SQL Developer, is right-click on it and just select Connect. Now I have a connection with all my um, uh, table space objects. Going back here to the comments that I have, there's a couple nuances that I want to talk about, and I've already started with here about how Oracle treats integers and the number data type. Oracle has what's known as character substitution or string substitution. And it's a bit odd. And I'll explain it like this. So here let's just first read these notes here that I made. And I get this documentation from mostly the Oracle documentation and sometimes also just by doing my own research on other sites that corroborate that and perhaps give a bit more um, information that sometimes the documentation is a bit sparse. It's not, or maybe could be further explained with an example, which I'm going to provide here. So by default, Plus treats the AND symbol as a special character that begins a substitution string. This can cause problems when running scripts that happen to include the AND symbol for other reasons. So this is a logical one, right? And this is one that I got directly off the internet. You have here a customer's table. Obviously, you know it's not my table because mine are always singular, correct? Customer name, I would call that cus underscore f name or cus underscore l name or just cus name if it was a store perhaps or a company, but like it looks like in this particular situation. Now that's not going to be treated the way you would think it would. If you ran this without setting line 44, which I purposely commented, you would see when you ran it that Oracle SQL Developer will prompt you for a string substitution. And if you want it to be included as per it would seem logical here, Marks and Spencer's Limited, then you would just set define off in your code. But if you wanted to set for string substitution for whatever reason, which you could for special circumstances, you would be prompted at the point of insertion for a substitution for the word Spencer's, which shortly an example will clarify exactly what I'm saying. Okay, now a couple things here. You'll notice in my drop table here on line 83, I have a couple things other than drop table. I have drop table customer, cascade constraints, and purge. Now, what does that mean? Here I got some notes here. of what cascade constraints is. When you specify cascade constraints to drop all referential integrity constraints that refer to the primary and unique keys. So if you make a unique key, like for say, you want a social security number to be unique, which you should. So you would make that unique. You wouldn't make it a primary key, but it would be a unique key. So when you specify cascade constraints to drop all referential integrity constraints that refer to primary and unique keys in a drop table, if the clause is omitted, so if you do not explicitly indicate cascade constraints, and there is that particular referential integrity, the database will return an error. So in other words, if you have a primary key, foreign key relationship, then you want to make sure that you put cascade constraints. It's essentially like cascading any type of referential integrity from a parent table to a child record, child table. It will delete those child records associated with all of the parent table primary keys. So you want to make sure that you do that. Now, there's another peculiarity here, and that's the purge keyword. And what does purge mean? It means that you will not release any memory back to the table space for other objects if you only use the drop table statement. So if you want to release memory for that table space, you want to include the purge keyword. And so I also put here in line 51, moreover, the space continues to count towards the user's space quota if there is a space quota, which as a DBA, you can actually indicate how much table space that you allocate to users. So if you don't use that purge keyword, the table space will not be reclaimed. So what we want to do is include cascade constraints as well as purge. All right. Line 53, as a special reminder, do not include the drop database command, okay? As your tables are created in your own table space and not a database. So do not use drop or create database command. Just connect to it as per step number 1 and then start creating your tables and populating them, okay? So again, step number 1 is that you would connect to your schema. Now, one side, before you start creating your tables, you should set define off. But for some specific reasons, excuse me, you may want to do string substitution. And I'll show you how that works. But for the most part, you don't want to do that. And you'll see here in a second. But if you we're creating normal tables, you would want to set define off before actually creating these tables. All right, how do we create auto increment in Oracle? We simply do it like this. Look at line 62. This is the commented version. In the code that I'm going to give you, though, I'm going to give you more information as I usually do, as you know. But the simple way here would be line 62. Create sequence, the name of the sequence, and then what would happen with that in a semicolon, of course, it would start with 1 and increment by 1. Here, as per tables, the first thing you want to do is drop the sequence and then give it a name. And what I like to do is just prefix it with the SEQ prefix, and then what is the actual name of the attribute that you want to have as the auto increment attribute. For us, in this table, it's going to be cus ID. So drop the sequence SEQ underscore cus underscore ID, create the sequence. Now here, we could actually give it, and there's actually more options than this as well too, but I'm just keeping it simple here for you. You use the keywords start with 1. These aren't comments, by the way. This is a sequence definition. Start with 1, increment by 1, min value is 1, and max value is 10,000. Don't forget, no commas in your numbers. Every time you put a comma in there, it stops it starts parsing the values. So wherever that comma is, it'll parse it to the next value. So you don't want to have commas in your numbers. So this is the longer version. This is the short version, is line 62. Just create sequence, name of the sequence, and it would start with 1 and increment by 1. Okay, that's how we create sequences. In some people's code, if you go online, you'll see that they create all their sequences at the top of their file and then their tables. My preference, and that's fine, but my preference is to create the sequence above every table that I'm going to be using it. And that's just my way of doing my creation. If you want to put all your sequences at the top, that's fine. I like to put mine right above each table. So this sequence is going to be used for the customer table. Next, another anomaly is varchar versus varchar2. Okay, the Reader's Digest version is varchar is reserved by Oracle to support the distinction between null and empty string in the future. By the way, I should have said this first. Line 78. Currently, varchar and varchar2 is exactly the same. The recommendation is to not use it though, because in the future, it may be given a different definition. So what is that definition? It says here, varchar is reserved by Oracle to support the distinction between null and empty string in the future, as the ANSI standard prescribes. Varchar2 does not distinguish between null and empty string and never will according to the documentation. So if you rely on empty string and null being the same thing, use varchar2. Here's a reference that you can have. By the way, that's a Stack Overflow reference. And here is the actual documentation from Oracle. And let me go here just for a second. Okay, this is the actual documentation. Let me make that a little bit larger. Okay, you could see that right there from the Oracle site. Varchar data type is synonymous with varchar2 data type. To avoid possible changes in behavior, always use varchar2 data type to store variable length character strings. But again, for now, they're treated the same. Okay? All right. Bottom line, be safe, use varchar2. Let's go into the table creations. You'll notice I already talked about this before, so I'm not going to elaborate. I always use in my drop table statements, I drop the table and use cascade constraints. In other words, to eliminate any referential integrity issues that would cause errors. And I use purge, the purge keyword, to reclaim memory. So I use that in all my drop table statements. Here's a create table for customer. Notice I'm using number. Notice I'm using number with the cus ID as well too. And if, for instance, I wanted to limit the user to say no more than an integer, no higher than 999, I would do something like this, 3, 0. Okay? That 0 is the scale and would indicate that the largest value that the cus ID could be would be 999. Precision, 3 digits, 0, scale, no digits to the right of the decimal point. Okay? Everything else here, gang, is pretty much the same. We already talked about the varchar2, so nothing's different there other than using varchar2 rather than varchar. Cus F name, L name, street, city, state, zip. Notice what I did here for zip. And phone. Now, implicitly, gang, these are saying that there's no scale, which would be equivalent to this. Okay? And I'll even put that there. So, equivalent to number 9, 0. And I'll just take this out. Okay, so what are we saying here is that we're allowing 9 digits for zip, 10 digits for phone, 100 for email. Balance, again, gang, this would be equivalent to this. right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 2 digits to the right of the decimal point. That would be the highest value that we could use. So if you wanted to know here, it would be $9,999,999.99. Of course, you cannot put commas in your numeric data. Primary key, use a constant keyword, name the constraint keyword, name whatever a constraint you want to call it, just PK underscore customer. Notice that's different than the actual attribute, okay? We don't even have to do this if we don't want to, right here. We don't have to do that. But it gives clarity if we wanted to change, for whatever reason, we wanted to change the definition of the primary key, we'd have to know the primary key to make an alter to that table. So giving it a name allows us that opportunity. So give it a name. That's what the constraint keyword is. We're going to call it PK underscore customer, and the primary key, of course, is cus underscore ID. All right. Moving a little bit more quickly. We're going to talk about sequence. We're going to have a sequence for the commodity table. That's it right there. Same sequence up to 10,000. Here's a commodity table. So notice we have a customer table, a commodity table. Both of them are strong entities, and neither one of them have foreign keys. So commodity ID, commodity name, commodity price, the constraint is going to be the primary key is going to be a com ID, and then we're going to make the commodity name unique. And this is how we do this. We put the constraint keyword, and by convention, what I use is UQ for unique, and com name, the name of that particular attribute, and the unique keyword to indicate which attribute is actually going to be unique. By the way, gang, this is case sensitive, so don't be misled. So if I have a commodity name, say whatever, baseball. Okay, that's the commodity that we're discussing. Baseball would be the commodity. It's an item, if you will. If I spelled it uppercase and lowercase, that would be considered two different commodities. So be careful with that. Just because it's unique doesn't mean that Oracle is going to catch it. Oracle will only catch it if it is spelled exactly the same way. Now, there are workarounds to this, but they're not easy workarounds, unfortunately. So just remember, when you use a unique keyword, that means it is case sensitive. So what you could do on your own is do some research on how to enforce case insensitivity when using the unique constraint. So if there was a commodity name spelled differently, uppercase, lowercase, camel case, whatever, that it would catch that. You'll find that there's a couple things that you can do, but not particularly intuitive as far as that goes. Okay, not particularly intuitive. Unique constraint. I got some notes here about the unique constraint and how they could be used. And creating indexes. I'm not going to go into these too much. I just have some notes there for you. So if you want to take a look at those, you can and use those. I'm not going to go into the detail of them, but you can see how you can actually show your constraints here with some code, and you could list all your user constraints here like this. You can also show the specific user constraints and the constraint name. It would list it like this, and there's Oracle documentation for that as well too. And also a key or a legend, if you will, of what those constraints are. So the on line 150, P constraint stands for primary key, R is for referential integrity, C is for a check constraint, for instance, a not null or unique. No, my apologies. No, C wouldn't be for unique, but C would be for a is a check constraint. So not null, or perhaps if there's a range of values, that would also be a check constraint. Okay. Again, Oracle documentation. You want to list a short list of the constraints. You could do something like this: select constraint name, constraint type. From user constraints where table name equals commodity. One thing, gang, it's a bit odd, but if you create your tables in lowercase, like I did right here, Oracle does not acknowledge it. It automatically turns it into uppercase, which is a bit frustrating. If I wanted to make it lowercase, I would specifically have to put quotation marks around it, which is odd. But nevertheless, it's Oracle. It's an Oracle-ism. And I'll show you that here shortly when I actually populate this. So what I would have to do to see the constraints for my commodity table, this line 144 and 145 will not work. I'd have to do this unless I specifically created the tables with quotation marks around there. Okay, so that's that. I got two tables so far, customer and commodity, and now I have an order. Okay, I'm not going to go into detail of the sequence. You have that over here. And for the order table, pretty much the same. With order, though, order is a keyword. And I used order specifically like I did in MySQL, like I did in SQL Server, to show you that you can still use reserved words with your database, with your table creation. However, they're treated differently, right? MySQL uses backticks. Uh, Microsoft SQL Server uses square brackets. Oracle, you have to put double quotation marks around them. Okay, but you can still use that reserved word order, which we did. All right, what do we have here? Now notice that order ID, the max value can be 9,999 because we used the number four as the first argument, our precision, and 0 for our scale. Cus ID is going to be our foreign key. Commodity ID is going to be our foreign key. They're both numbers. And order number of units, that's going to be an integer. Total cost is going to have, because it's a cost, we're going to say that it can have 2 digits to the right of the decimal point for cents. Order notes, primary key is going to be order ID. Foreign key is going to be, one of the foreign keys is going to be cus ID, and the constraint, we're going to give it a name. FK underscore, the name of the table in which it resides. Well, it resides in the order table. Cus ID resides in the order table. And the name of the table to which it points. It points to the customer table. Okay? So, and the references means that it references the cus ID primary key in the parent table of customer. Another foreign key is com ID. So the table in which it resides is order. The table to which it points is commodity. Foreign key is com ID. It references the commodity table and the primary key of commodity. We got two constraints here, you guys. The constraints are on, we call it check unit, and it refers to the number of units must be a positive value, just like the order total cost must be a positive value. Notice that the constraint names are different than the actual attribute names. Okay? And then finally, we have our data. So let's look at this. Remember we made our sequences, right? I'm going to show everything here. That's all your code that you need right now. So we have 5 records for the customer table, 5 records for the commodity table, and 10 records for the order table. Notice again, order, because we're using the order keyword, has to be in double quotation marks. Notice also, this is how we use auto increment. We created our primary key, right? We created our sequence called seq underscore cus ID for the customer table. And then we're using that with the next val function. So essentially what it's going to do, it's going to order this 1 through 5 right here for this particular sequence. We're going to get 1 through 5. And so we're going to have the cus ID being 1 through 5. But this is how we do auto increment in Oracle. Everything else is pretty much the same like we would do in MySQL or SQL Server. Okay, but just keep your eye on the next val function and how we use sequences to do that. One other gotcha with Oracle. If you did not use the commit keyword here after all of your inserts for each table, they would remain, if you did a select after you did this without the commits, you would see all the data for customer, commodity, and order. However, after you disconnected, logged out, came back in, if you did a select all from customer, commodity, and order, you would see no data. Okay? So realize that by default, and you could change this, you can go into tools and preferences and change this. And as a DBA, I can change this as well too. But I don't, because I want you to realize that Oracle by default does not auto commit. So what you have to do, just like the SQL standard, it follows it exactly. The SQL standard states that the transaction begins with the first SQL statement, not using the begin transaction or start transaction like we do in MySQL and SQL Server, because those DBMSs auto commit by default. Oracle does not. So the first insert will start the transaction. Now, if we want to commit it and we want it to persist after we log out, we must use the commit keyword. Okay, and I have notes here. Okay, Oracle does not auto commit by default. The DML statements, that is the data manipulation language statements, will only last for the session. When forgetting to commit DML statements, for example, with inserts, selecting the table will display no rows selected, like you didn't do anything. So if you want to get credit for this exercise, make sure you commit after each of these insert blocks that we do for each of the tables. So you would commit after customer, you would commit after the records in commodity, and then finally you would commit after the records in order. Okay, now the only thing I'm going to draw your attention to is the and symbol for a commodity. Remember I told you about not setting a define off? Watch what happens when I finally run all of this code here. You'll see that it'll prompt me to do a string substitution for player. Okay? Now, why is that? It's because of this. I failed to put, or I should say, to set define off on line 44. I did not do that. So watch what happens. But before I show that, I just want to make sure that you have all the records that you need. So these are the 5 records for customer. These are the 5 records for commodity. These are the 10 records for order. Okay, notice, gang, that you have to make sure that your foreign keys match. The primary key for order ID is right here, so we don't have to worry about that. But remember that our commodity ID and customer ID can only be values 1 through 5, right? Second rule of database design. Foreign key must match value of the primary key in the parent table or may be null depending upon the business rules. In our business rules, we're forcing that these foreign keys cannot be null. Okay, and then after that, what we're going to do is just show the three tables. All right, so let's run this. I'm going to highlight all this. I'm going to copy this. I'm going to go to Oracle SQL Developer, and then what I'm going to do is I'm going to paste all of this code like this in here. Now there's two ways that you can execute this. If I execute it with F5, it'll show my code in text mode. And then I could also show it in grid mode, and I'll demonstrate that here in a second as well too. But first I'm going to show it in text mode. I'm going to hit F5. Now watch the prompt. There's my prompt right here, gang. And look what it highlighted. It highlighted DVD and player. So what I'm going to do is I'll put, so let's see, instead of player, I'll put DVD only. Okay? And I'll put only instead of player, hit OK, and watch what happens now. Because I have select on customer, order, and commodity, watch what it'll display. And you'll see here that it says DVD only. Okay, it prompted me for that string substitution. Okay, and there may be some specific reasons why you want to do that. But for the most part, you probably don't want that. So what you would do is just go back to your code and make sure that you set define off. Okay, and you'll see when I do that, that it won't prompt me for that. It suppresses that prompt. Okay. Let's see. What else did I want to show over here? Um, the Well, one is that when I do a select all, notice that the attribute names are all uppercase, even though I didn't create them in uppercase. That's a Oracle-ism. Now, interestingly enough, when I did the select all lowercase, it acknowledged it. But watch what happens when I try to find my check constraints, which is a bit odd. So I'm going to come back up here, steal some code that I have here, and I'm going to show you what works and what doesn't work. I want to see my check constraints. And so let me go back up here to this. Okay, I'll show you the example that does not work. Okay, select all from user. I want to see my table constraints for commodity. I go back here and then I will select all, paste, and then hit F5. Oh, by the way, I do want to say something. You're seeing what Oracle does. It keeps appending the result set from the prior execution of code. It keeps appending it. So if you don't want to see it, if you want to see it clean, you can go here to this icon that has a little erase on it. Or what I like to do is just do Control-Shift-D. If you forget, just hover over it and it'll tell you exactly what that icon is for. So I can clear this query result set here. I could pin it if I wanted to. That's what the pin is for. I could save it if I wanted to, just with this icon right here, save the file. Control S. I could print it if I wanted to, or I could even run the script output as a script if I wanted to, and that would be Control F5. But what I want to do right now is I want to delete this. So I'm going to do Control-Shift-D, delete that. I'm going to run this again so you can see clean output. Hit F5, you'll see no row selected. Yeah, but I got a table name commodity. Doesn't matter. Oracle doesn't acknowledge it. What you have to do is you have to do it even though we created a commodity table in lowercase. What we have to do is we have to put it in uppercase. Let me now do Control-Shift-D to remove that. Run this again. F5. And there it is. Here are all my constraints that I have so far and the tables in which I have those constraints. Okay? So it gives me information about the constraints. So here I got commodity, com ID. Well, the constraint is its primary key. Here I got commodity, that it is a comp price. Doesn't give a whole lot of information. If I wanted to see a bit more information, I could do this as well too, running the constraint name. Now watch me when I do this. First thing I'll do is Control Shift D, get rid of that output, and Control A, Control V, and then I got to spell the table name correctly. So capital C-O-M-M-I, no, I'm sorry, O-D-I-T-Y, and the particular constraint name. Well, I don't know what that name is, so I'll just put this semicolon, and then I'll do my F5 again. I got, oh, okay. Let's see. So I want to find out constraint name is, what is that? Let me do that one. What is that? So I can paste that back in, and I'll do this as the constraint name. And I can get specific information on this. Okay, that, by the way, that's a system constraint. So when you see CIS, or I'm sorry, CYS, that's a system constraint. So I'll just do something like this and paste that in there. I'm going to get rid of this output, Control Shift D, or again, I could have used that eraser icon. And now I'll print this out again. I left a semicolon there by accident. F5, and it gives me more information about that particular constraint name. So it says search condition, com ID is not null, and then I could scroll over to find other information here, the constraint name, etc., etc., etc. Now, that's not a very intuitive display. I'm going to do Control Shift D again, get rid of that. And now what I'm going to do, if you want to see it in a grid view, just select all. I do Control A, and then hit F9 instead. Now notice when I do it this way, I see it in a grid view and what that information is. It gives me more detail about that particular constraint. If you want to find out more about the constraints, gang, you could just do a search on the Oracle site. The last thing I'm going to do, you guys, here is this. I'm going to highlight everything again, and then I'm going to run it in using the grid view. Okay, so Control A, Control V, paste that in. What you have to do for the grid view, you guys, is select all of the code like that. You don't have to do that when you use F5. But if you want to do F9 and you want everything to execute, just select it all, then hit F9. What happened here? Did I forget to do that? I may have done that. I think I may have forgotten to do the define. Yep. No, I got define. I think it's because I left it on. I had it in my buffer already. So it's prompting me for that again because I left it in my buffer. There it is right there. Sorry about that. And that's my bad on that. I'll just say DVD. I'll say player this time. Okay? And hit OK. And you'll notice what I have to do to see these result sets is just click on those particular tables like that. Okay, gang? If you have any questions, please let me know. Send me an email, post them to the discussion board. But again, be sure that when you are running this, make sure you put set define off so you don't get those continual prompts. Okay? All right, gang. See you all in class.